Topic 15, Empirical Formula. Video B, Percent Composition. Part 1, Let's Practice 2 Walkthrough by Jessica Lau, Lucy Gao, and Mei Qi Ng. Question 1. A compound contains carbon, sulfur, and chlorine. The compound is 10.4% carbon and 27.8% sulfur. What is its empirical formula? If you add 10.4% plus 27.8%, it will equal 38.2%, which you will subtract that number by 100. This will equal to 61.8% of chlorine. In order to get the number of grams of each element, you will have to divide each percentage by 100. Therefore, you would have 0.104 grams of carbon, 0.278 grams of sulfur, and 0.618 grams of chlorine. To find the number of moles of carbon, you will have to divide 0.104 grams by 12.011 grams per mole. This will equal to 0.008658 moles of carbon.
For sulfur, it will be 0.278 grams divided by 32.066 grams per mole of sulfur, which will give you 0.008669 moles of sulfur. As for chlorine, it will be 0.618 grams divided by 35.453 grams per mole of chlorine, which will equal to 0.017431 moles of chlorine. Now that you have all the moles of the atoms in this compound, you will divide every atom by the smallest mole out of all of them, which is 0.008658. For carbon, you'll get 1. For sulfur, you'll get 1. For chlorine, you'll get 2. Your mole ratio is therefore 1 to 1 to 2. You use that mole ratio for the formula CSCl. Plug it in, and your empirical formula is therefore CSCl2. Question number 2. If a compound of molar mass 84 grams per mole has the empirical formula CH2, how many atoms are in one molecule of this compound? You'll need the periodic table to find the molar weight of carbon and hydrogen. So, for CH2, you'll need to find the molecular weight of this, which is 12.011 grams plus 1.008 grams plus 1.008 grams, which will equal to 14.027 grams, which is approximately 14 grams per mole. And so, the molecular weight of CH2 is 14 grams per mole. You'll then do molar mass divided by the molar weight of CH2, which is 84 grams per mole divided by 14 grams per mole, which will give you 6. Now that you have gotten 6 from the molar mass divided by the molar weight of CH2, you will then multiply 6 to every atom in the empirical formula, which will give you C6H12. So, you know that there are 6 atoms of carbon and 12 atoms of hydrogen. Add them up, that will give you 18 atoms in one molecule of C6H12. Your answer is therefore 18 atoms for this question.